Hi class. Today we'll be covering significant figures in calculations, chapter 2.3. Just to be sure that you should make sure that you are comfortable with the prior two sections before you go on because all of these build on top of each other. And if there's anything that you feel rusty on, make sure you have it out while you're watching these or when you're doing the homework or any of the examples. There's a lot of rules. Make sure you have a copy of them or write them out so you always can see them and learn from them as you're doing the problems. So measurements and calculators. In science, we measure everything and anything, and most of the time we do it with a calculator. Calculator is the best thing in science. However, it's not exactly, it runs short on certain things, and that's what we're going to cover right now. So you can plug in to get your answers, but what calculators don't provide is they don't provide the final answer. You will still have to follow sig figs, you'll still have to follow rounding rules, and one of the limitations in calculators is that it also doesn't always provide you with correct number of values, number of digits. For instance, you may plug something in and you'll get one digit answer back when your problem that you're working on is actually 3 sig figs. So we need to cover the limitations of a calculator. So before we do that, we have to cover rules. Rules for rounding off. So if the first digit to be dropped is 4 or less, then it and any numbers or digits behind it or next to it that are going to be dropped. So anything that's not going to be part of the sig fig, we drop. The second option is if the first digit to be dropped is 5 or greater, then the last retained digit of the number is increased by 1, and then we drop everything. It's easier to go over this with examples. So here are some examples. Number to round off, 8.4234. If we wanted to round off to 3 sig figs, we have to figure out where. 1, 2, 3. And it's going to drop off here. So the number that is closest to what we're going to keep, 2 is what we're going to keep, 3 is what we're not going to keep. We need to know if we need to round up or don't do anything. So since this is 3, it is 4 or less. We do nothing and simply drop it. Now if we want to go to 2 sig figs, we count 1, 2. Same rule. We're going to keep 4. So we need to look at 2. 2 is obviously less than 4. It's 4 or less is what I should say. Then nothing happens. So we're just dropping the numbers. Now let's look at this one, 14.780. We want 3 sig figs. So 1, 2, 3. We're going to keep the 7, drop the 8. Now this fits number 2. It's 5 or greater. So we're still going to drop the 8 and the 0, but we're going to add a 1 to the 7. So our final answer is 14.8. Now we want 2 sig figs. This one tends to mess up students, and just follow the rules, even if you don't feel that it's right. If you're following the rules and you've done the calculations and math correctly, you're fine. So this is 2 sig figs. So we want 1 and a 4. So the number we're going to drop is 7, 8, and 0. 7 is above 5, so we're going to add a 1. So it's going to be 1, 5, and there should be a decimal point. We will drop the 7, 8, and the 0. Next one, 3256. We want 3 sig figs. 1, 2, 3. We're going to keep up to 5, but 6 is greater than 5, so we're going to add a 1 and then put a 0 here. We're going to put a 0 here because it's a placeholder. We don't have 3,256. By the time we're done, we'll have 3,260, not 326 if we were to drop the 0. We need to understand place values so that we can always retain the actual value that you have here. This is like having $3,260 and you're getting shorted for $2,325 because somebody's not giving you the place value that you rightfully deserve. So by dropping the 6 and adding 1 to the 5, our final answer is 3260. Now what if we want 2 sig figs? So if we want 2 sig figs, we're going to keep the 3 and the 2. Now we need to still keep place values here, but we want the 3 and the 2. So we have a 5, which means we're going to add a 1 to the 3. So that's going to be 3,300. The trailing zeros here have no decimal point, so they are not significant. This is still 2 sig figs. Remember, the zeros are placeholders in some place so that we understand we're dealing with 3,000 and not 300. So here is something for us to go through. Write the correct value when 3.147 grams is rounded to each of the following. So here we want to round this to 3 and then 2 sig figs. So let's take a look. We want 3 sig figs. So 1, 2, 3. 5 is a number we're going to drop, but it's 5 or above. So we should add a 1 here. So our answer should be 3.15. We're going to drop to 5.7 and increase by 1 because this is 5 and above. So let's look at the bottom one. We want to round to 2 sig figs. So that means 1 and 2. 4 is 4 or less. So nothing's going to happen. We're simply going to drop these off. And that's exactly what we get. We drop to 4, 5, 7. Do not increase because it's not 5 or above. And our answer is 3.1 grams. Now, multiplication and division are one of the first rules. So first of all, this is rounding. Now we are on to actual rules that deal with our calculations, and you will never escape these rules for as long as you are in chemistry. And students have a problem with them because some students choose not to learn them correctly. Make the effort to know there's a big difference between the multiplication rules and the addition and subtraction. And these are the things that actually cause errors on your exam and your quizzes, because you know how to do the problem, but if you don't know how to do the rules, you're not going to get the answer correct. So multiplication and division, measured numbers. In multiplication and division, the final answer is written so that it has the fewest, so it has the same number of significant figures as the measurement with the fewest sig figs. In simple terms, you look at the problem and you look at what you have to work with. This is 24.66 centimeters. This has 4 sig figs. This is 0.35 centimeter. This has 2 sig figs. The 0 in the front does not matter. And by the way, when you have a decimal point, you always write a 0 in front if there's no number value. This is just sort of etiquette. So we're going to multiply this on the calculator. And the calculator is going to give you a large number. Now we have 4 sig figs and 2 figs. This rule states that the amount of sig figs that you'll have in your answer is by the value with the smallest amount of digits. So this is 4, this is 2. My final answer is going to be in 2 sig figs. So 1, 2, 3. 3 is a number we're going to drop, but it's less than 4, so nothing happens, and our answer is 4.6 centimeters squared. When we multiply, we also multiply the units, which is what we have here. So make sure you're understanding how to do the multiplication for the units, or if we had to divide units as well. Understand the calculator is not always going to give you the value that you want. You'll have to actually have the knowledge of the rules that we're covering in order to make sure you get the correct answer. Here is multiplication and division one. So we have 21.5 centimeters times 0.30 centimeters. This is on top. Under is 1.88 centimeters. So, the denominator. First thing you need to do is take care of the problem at the top. So you're going to multiply this. I added parentheses because when I do this on a calculator, I want to make sure that I specify that this is to be done before this one. So I multiply this together and then I divide by 1.88. This gives us an answer of 3.43 and a whole bunch of numbers. Now, multiplication and division, we look at the overall values, and the number that has the smallest amount of values to it is the one that's going to match our sig figs that we need to use. So this has 3 sig figs, this has 2 sig figs, and this is 3 sig figs. So this is the value that has the least amount of digits to it, and the 0 here is a trailing, but it has a decimal, so it counts. We are going to take our answer and make sure we round it to 2 sig figs. So 3, 4, and 3 is below. We don't need it. So we're just going to simply cut this part off, and our answer is 3.4 centimeters with 2 sig figs. Now keep in mind, we had 3 centimeters unit here. We have 2, so this would have been centimeters squared, and this is centimeters. But dividing a centimeter into centimeters squared, we cancel out 1 centimeter, leaves us with 1. Adding sig figs. So this is the problem that I was discussing with calculators. You can add in or punch in numbers and what you're working with, and sometimes you'll get a 1 answer digit, and your answer is not 1 answer digit. Your calculator doesn't know. It simply follows a program. you have to be aware of the problem and make sure that you fix it if this happens. So adding, when the calculator displays fewer sig figs than you need, add one more or add more significant zeros, add one or more significant zeros to obtain the correct number of sig figs. So in this case, we have 6.0 grams over 2.00. The one on top has 2 sig figs, the one on the bottom has 3. So looking at this, 6.0 has the fewest, so our sig fig number is going to be in 2 digits. But when we plug this into a calculator, we get just 3, and that's not correct. We have 2 sig figs, not 1. So we have to be able to make sure that our answer is correct by adding a 0. That's a placeholder. It's still giving us our number, but we are matching the sig fig rule. So our answer is actually 3.0 grams. So here's another problem. Performing the calculation of measured numbers. This is a multiplication and division. So overall, the answer needs to be with the value with the smallest amount of digits, and we can easily see that's the lowest one below on the denominator, excuse me. This is 2.0, so we should have 2 sig figs in our final answer. We need to make sure you understand the multiplication and division rules. It's quite different from addition and subtraction. We need to answer this the correct sig figs, and we need to make sure we understand the rules for rounding or adding zeros. So here is the problem worked out. Again, this one doesn't put parentheses because we didn't need it. They did it in separate steps. Here it looks like, here they multiplied this first, which is always what I would do. Do this first, then divide it by the final answer. So this ended up being 8.52. However, I just told you earlier that the smallest digit needs to match the value in the problem. So this is 2. So we are going to adjust our answer. So again, we had centimeter squared, centimeter, and centimeter squared, but we divided by a centimeter, which ended up giving us only 1 centimeter in the problem. And with 2 digits, so we dropped the 2 because it's below 4. So our answer here is 8.5 centimeters. Now we're in addition and subtraction. This moved on me. I apologize. It wasn't like that when I fixed this. Addition and subtraction is very different than multiplication and division. We do not care about, in the simplest terms, let me read this and then I'll explain it. In addition and subtraction, the final answer is written so that it has the same number of decimal places as the measurement with the fewest decimal places. What this means is this whole thing is talking about decimal places. So unlike multiplication and division, what matters here and takes priority is where the decimal point is and how many digits are after the decimal point on the right. So here we have, let's take a look here. We have 2.012. This ends in the thousandths place. 61.09 ends in the hundredths place. Oh, this messed up my decimal points. I had these all lined up. I used Google Docs and then I downloaded into something else and it messed it up even though I checked it right before I saved it. I don't know how it did that. And then we have 3.0. It's tenths. So unfortunately, I apologize. It might do this with the rest of the problems too. I did check these and for some reason then when I saved it, it didn't save right. So if we line these up, you can see this is tenths, this is hundredths, and this is thousandths. This problem only cares about, we don't care about what's on this side. If there's numbers on this side, we're not worried about them. We want to know how many digits are after the decimal point. This is the tenth. So we're going to only have digits matching the tenth on this side, and however many numbers we need on this side does not matter. So unlike multiplication and division where we care about the overall problem and how many digits, here we worry about where the decimal point is, and that's going to determine the right side. We're not worried about the left side right now. So if we plug this in to a calculator, your calculator gives you 66.102. Remember, we're in the tens place, so if there was a line, which I think it's gonna mess up my other slides, you're gonna cut it off. 0 is below 4, so we drop it and it's 66.1. Well, this one managed to stay. Okay, that's weird. So if this one is lined up, this one should have been, and I don't know what happened to it. But what I do, if you have problems keeping the rules separate, addition and subtraction are not always easier to see what placement the decimal point is. So draw them out where you line the decimal up And then if you need to draw a line where the smallest digit is, then this tells you where your answer should be and the next digit that needs to be rounded. Drawing a line is really beneficial when you're first learning how to do these. Same thing here. So if we subtract, we have 1 in the hundredths, 1 in the tenths. Draw a line. This is going to be the last digit. This is above 5. We round it, and it gives us a number. Notice I'm not talking about the front side of it because addition subtraction only cares about the back side of the decimal point, right side of it. Again, here's another problem. Make sure you understand the rules for addition. In this case, same thing. This has the digit in the 10th place. So this one's going to determine our sig fig rules. We add it together, draw a line if you need to. And last digit is 4 because it's in the 10th place. 0 is below 4. We do not round, we drop it off, and this answer is 104.4 milligrams. I've added a couple more examples since students tend to have more of a problem with addition and subtraction than they do with multiplication and division. Pay attention to where the decimal points are with place settings, and this will you'll start seeing a pattern of what you need to do and where you need to drop it. Just remember the overall of understanding these rules is they are two entirely different rules. In addition and subtraction, the priority is where the decimal point is and what digits lay on the right side of it. Excuse me. Okay, thank you.